Okay, we're in section 9 of the notes now, and it's the section on logarithmic functions. We covered the material. Logs are the inverse of the exponentials, and so we went through a bunch of examples with graphing them and talking about the nature of logs. Hopefully you've understood what was presented to you, particularly how exponentials and logs are related, how you came up with some certainly rules of manipulation for logs, how to graph logs, and how to use logs, some basic rules. We went through all that material. I hope you're able to follow that. And again, we reinforce it in the examples. The deal is this, though. You have to go back over that material and study it and make sure you understand the examples that were presented to you. But again, the deal is you want to be able to do material on your own. And that's why we have supplemental exercises for you to try. The hope is that you've studied the material that we presented to you. You've worked through all the examples that we did together. You try to understand those examples, and then you're at the point where saying, well, gee, I need to try these things, see if I can do that. And that's why we write some of the problems. And that's where we are right now, these activities. So I'm going to go through the activities for you, and I'm going to switch to the whiteboard again, and we'll walk through it. All right, so give me a moment here. And I'm going to switch over. All right, give me 1 second. I'm going to insert the notes now. I forgot to do that prior. Do it now. And what page are we on? I guess page 198, right? Boy, it's a long document, isn't it? Let's take a look at this. And let's insert them. And let's start doing the problems. So number 1, certainly I'm going to just pull it to the side. All right, so use definitional logarithms to evaluate the log base 6 of the number 1. Well, let me write down what I mean by that. I'm going to say log base 6 of the number 1 equals something. And I don't know what it equals. So I'm going to use what I know about this, which is to rewrite as an exponential. So I want to point out what that means to me. 6 raised to x would equal 1. Write that down. 6 raised to the x would equal 1. Well, I'm hoping by looking at that, you now know x must be 0 because 6 is 0 is equal to 1. So I'm going to say log base 6 of 1 equals 0. That's certainly right there. Let's go to problem number 2. Number 2, a little more complicated. And again, what I mean by that is it's going to require the use of technology to do that. But I'll just kind of talk about this, and I'll talk through this in a bit. All right. So as I look at this over here, both on the side, and we'll talk about this in when we start using technology as well. Give me 1 second here. And I'll read it to you. What does it say? It says the model where T equals, this looks complicated, it says approximates the length of a home mortgage of $150,000 at 6% in terms of monthly payments. In the model, T is the length of the mortgage in years. It's important when you're reading these things that you can always go back and reread it if you can't remember what they said, right? It goes on and says X is the monthly payment in dollars. It says use the model to approximate the length of $150,000 mortgage at 6% when the monthly payment is blah, 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 blah. And they give you 2 different monthly payments. So basically it's a plug-in formula. So let me point out what I mean by that. You're given this over here, right? It's nice to be given something. The question is, you might say, I don't know what these letters mean. And, X is the monthly payment. All right. Now, someone says, I don't even know where that is. It's right over here. X is the monthly payment in dollars. All right. So I'm looking at that. And I'm going to say I could definitely plug in those numbers in the formula. And what I mean by that is looking back over here, I'm going to say This is just the formula that they've given me with the monthly payment of $897.72. What does it return T? What's T? T is the length of the mortgage in years. So if you have a mortgage of $150,000 at 6% interest, what you're going to find out if you plug that number in of a payment, $897.72 per month, it would take you 30 years of paying that amount per month. Now, if you did T2, that's a bigger payment, right? It's $1,659.29. That would take 10 years to pay off. All right. So let me look at, B. B doesn't look too difficult. So it's approximately the total amounts paid over the term of the mortgage with a monthly payment of $897.72. All right. Now, granted, I realize this may be overkill for you, and for some students it is. And again, I'm not opposed to it. If you took this number here, though, right, and that's going to take 30 years, right? So what would that be? That would be 897.72. You're doing it monthly, 12 months per year times 30 years. Now, if you did this, these numbers are not going to match up. The reason for that is that payment really doesn't meet the obligation of the loan. This is the exact number that's being computed over here. When someone says, what do you mean by that? This number over here is not exactly 30. It's not 30. What is it? It's approximately 30. Just like this number over here is really not 10. It's approximately 10. It's not 10 though. All right. So again, this one over here, if you looked at this one over here and said, oh, I'm paying $1,659.21 12 times a year for 10 years, I'm going to claim it's not going to match that number. It's going to be approximately that number, but this is going to be the exact computation. Make sure you understand the difference between the two. All right. People are often confused at the end of a mortgage. Typically, the last payment is either going to be a little bit more or a little bit less. It's never going to be the same. Okay. Let's take a look, or they'll refund or ask you for the difference. Okay. Let's go to the next one. And I guess I should really, the next one is the continuation. What's the amount of total interest for each loan? Well, the loan was 150, so you'd have to subtract away. Hopefully these things are kind of obvious what's over here. All right. Use trial and error in your head. I'm going to point out that does require a calculator. This is something that people often want to do. They want to pay off their mortgage quicker. And what they do is they try to, either up the amount they're paying or pay them more frequently, and they can do that. Again, this is a trial and error problem. What does that mean? You're probably going to need to use a calculator to do that. All right. All right. Let's go to number 3. And I'll pull it on the side. And I'm going to just see if I can understand what they've said. All right. So number 3, what does it say? Use the definitional logarithms to evaluate the function at the indicated value. So I'm going to write this down for you. So it's going to be log base 36, and x is going to be 1/6. Now I'm going to claim I don't know what this is, but now they're saying it's equal to f of x. I'm just going to simply say f of x is some number. I'm not going to use x, by the way. I'll just say y. So what I want to do is rewrite this not as a logarithmic problem, but as an exponential problem. So I'm not going to use a calculator. I just want to see if I can figure this thing out. So what's it going to be? It's going to be this. It's going to be 36 raised to the y would equal 1/6. Write that down. Okay. I'm going to get both sides into the same base. The left side is 6 to the minus 1. Well, 36 is actually 6 squared. So it's going to be 6 to the 2y. Now, what do I now know? I know that minus 1 has got to be 2y. So I'm going to write that down for you. So what's y? Y now is going to be minus 1/2. So what do I know? I know log base 36 of the number 1/6 is going to equal minus 1/2. All right. You should probably look at the answer key to make sure that you can agree with that. And if you can't agree with that, again, you need to get help with that. All right. All right. I've got a number 4. And I'll see if I can do that one too. Again, we're trying to learn logs. And what does it say? It says use the property of logarithms to rewrite and simplify the logarithmic expression. See if I can do that. I'm going to claim I don't know what the number is. I'll just simply, in this case over here, call it x. I'm going to write it as an exponential. It's going to be 27 equals 9 to the x. I want to write both sides on the same base. The base would be 3. So this would be 3 cubed. This would be 9, which is 3 squared. Let me write that down. I made a mistake there. It's going to be 3 squared. It's going to be 3 to the 2x. What do I now know? The exponents are equal. So that means 3 equals 2x. What does x equal? 3 over 2. So log base 9 of 27 is going to be the number 3 over 2. What do I recommend? Look at the answer key and make sure you can agree with that. All right, let's do number 5, which is going to be the next page. And let me pull it on the side. It should be relatively simple questions, by the way. It says rewrite the expression in terms of log ln4 and ln5. Here comes a problem. So why would you do that? We're just simply practicing is what we're doing. Let me write down 1600 though for you. So 1600, and I'm going to divide it by 4. And so why are you doing that? They're telling me they want to do that. So what does 4 go to 1600? 400 times. Now 4 goes into 400 100 times. 4 goes to 125 times. I'm actually done with the 4s. Now I'm going to do 5. 5 goes into 25 5 times. So ln 1600 is ln of 4 cubed times 5 squared. Let me read this to you again. Rewrite the expression in terms of natural logs of 4 and the natural logs of 5. I'm getting close. So I'm going to write this now. I'll write this on the side for you. ln 4 cubed plus ln 5 squared. All right, so I'm using that product rule. Now I'm going to do the exponent. There's going to be 3 ln 4 plus 2 ln 5. The goal has been met. I've rewritten this in terms of log 4 and log 5. What is it? 3 of the log 4s and 2 of the log 5s. And these are natural logs, by the way. Is that answer listed for us? And then make sure that is. I want to point out that's over here. It's right here. Again, different order, but it's really the same thing. 2 ln 5, 3 ln 4s. Okay, let's go to the next question, which is number 6. Pull it on the side. And what I'm going to do, communicate to you, is what they're asking me to do. And what they're asking me to do is they're asking me to rewrite this guy. They want me to condense them one step at a time. So take the first term. We'll do the second term and the third term, one at a time. So it's going to be log base 2 x to the 1/2 power plus log base 2 y to the 4th power minus log base 2 z cubed. All right. Now what are we going to do? When I see additions and subtractions, I can combine those together. It's going to be log base 2 x to the 1/2 times y to the 4th. Now minus z cubed, so it's going to be divided by z cubed. Let me simplify it a little tiny bit. Log base 2 y to the 4th power square root of x over z cubed. I condensed it. All right, look at the answer key. Make sure you're staring at that answer, and of course you're staring at that answer. All right, let's go to number 7. Let me see if I can do 7 here. Just give me 1 second. Whoops. All right, evaluate the change of base formula. So why would you do that? And I'll tell you the number one reason to do it is most calculators don't have log base 6. All right, so let me put the base change formula down for you. Log base A of x could be written as log base 10 of x over log base 10 of a, or log base a of x, because your calculator is base 10, by the way. It could be written as natural log of x over the natural log of a. Okay, so if you were to do this one over here, what's it going to be equal to? Well, I like to use natural log because it's easy for me to write down. So it's going to be natural log of 3 divided by 7 divided by the natural log of 6. Yep, you would need to use a calculator to do that. And if you did that in a calculator, you would get approximately minus 0.473. Right, let's go to number 8. Number 8 looks a complicated one. And as I do that, I want to emphasize if things get complicated, it's time for you to start thinking and doing. All right. So they want me to show this here. I'm pulling it aside. And let me just get rid of this stuff over here. And let me just see if I can get rid of that. And let me see if I can do it. All right, let's write this down. I'm too big on that one. So let's write this one. I'm going to show that f of x, I'll write this one over here, plus f of y is going to be equal to f of x plus y over 1 plus xy. Now let's write this down. What's f of x? It's given to me. What is it going to be? It's going to be log 1 minus x over 1 plus x. Plus, what's f of y? Well, that's pretty easy. It's log 1 minus y over 1 plus y. All right, that's not so bad. Let's keep going. And let's take a look at that. And that looks complicated. Let's see if I can get that to go into one log. So it's going to be log, and let's write this down. It's a product. So 1 minus x, 1 plus x, 1 minus y, and 1 plus y. All right, looks complicated. Let's see if we can do that. And I'm looking at that. And simplifying really probably wouldn't add much to it. But what I want to do is I want to look at what the other one is. I want to look at I just did this side here. Let's do this one. Right, let's write that, what that would look like. And again, I'm looking back at the formula, this one over here. So maybe I should write that one down. F of x plus y, 1 plus xy. Whoops, I went too far with that, didn't I? Let me get my eraser out. Sorry about that. And again, I for some reason, I know it's difficult. And I can't really follow. And the thing is, really basics are really what you're trying to follow over here. You're trying to find the basics. Now, I know it's equal to a log. This comes the tough part. I'm looking at that, what it does. I want to point out what it is. It's 1 plus its argument. And at top, it's 1 minus its argument. I got trouble. And I want to tell you what the troubles is. I'm looking at that. I need to simplify it. And we keep rewriting it. Log . All right, what do you get in the bottom? You would get, let's see, 1 plus xy plus x plus y. I'm multiplying top and bottom by the minor LCD. Top would be 1 plus xy minus x minus y. All right, now here comes a big question. Am I getting the same thing? Is this and this the same thing? Let's take a look at it. I want to look at one thing at a time, though. I want to look at the top. Are the tops the same? Let me multiply that. What would you get? 1 minus y minus x plus xy. Let's see if we got the top. I see the 1. I see the minus x. I see the minus y. I see plus xy. Now let's look at the bottom. If you multiply this out, what would you get? 1 plus y plus x plus xy. Did we get that? Well, let's see. I see the 1 plus x, right? I see the y, and I see the xy. They're both the same thing. Worked out beautifully. Let's go to the next one. And next one's number 9. And again, the work there is for number 8, by the way. Let's see, number 9. Now, my claim over here for a lot of students look at these, they wonder what they want me to do with this. And certainly, we certainly want you to read it, right? So what does it say? Because as soon as the following, there's two functions are given us. One is y1, one is y2. Now, someone says they don't even look possibly the same. What they want you to do is graph these two. So they want you to graph this, and they want you to graph this, right? Now, my gut feeling is I hope that you're doing this thing using technology at this point. And if you did that, your graph should look, I'm going to say they may not look perfect, but they should look like the ones I've given you. And we'll talk about technology used later. So the graphs are, figure 84, page 203. And they say they're not identical graphs. All right, we'll go through that using technology. It says the curve of y1 is only to the right. And I want to tell you why that is. If you look at this guy over here, is this guy's domain is going to be all real numbers except for 0. This guy's domain, x, must be greater than 0. Now, someone says, why would they be the same to the right of 0? Well, if you condense, I'll write this on the side for you. Whoops, made a mistake already. This would give me what? ln 2x, and then it'd be ln 2x to the 4th power, which would be ln 16x4. So the bottom line is they're really, manipulation reasons, they're really the same. But the problem is the domains are different, all right? And that's what that second thing is saying. Explain in English what happens. The domain of the first guy, x is greater than 0, and the domain of the second guy, the x could be any real number except 0, all right? We'll talk about graphing those things later. We go to the next page, number 5, and we're going to do problem number 10 now. Number 10 is an expansion problem. All right, I'll go through the stages with you, the stages that we want you to follow here. It's going to be log base 11, and it's going to be what? X, let's take a look at that, squared, z cubed, y5 to the 1/3 power. I'm going to take that 1/3 down. And what do you get? Log base 11, x squared, z cubed over y5. So I think I'm ready to expand that now. Over here, you're going to get 1/3 times log base 11, x squared, plus log base 11, z cubed, minus log base 11 y5. Again, some students are going to be faster than others at this. There's nothing wrong with going faster than that. We certainly want to match the answers that we're getting in the end and see if we can do that. What do you get up here? 1/3. This would be 2 log 11x plus 3 log 11z minus 5 log 11y. I'm going to multiply the 1/3 across. Looks pretty easy to do. What do you get? 2/3 log 11x. Well, 1/3 times 3 is 1. So you get log 11z minus 5/3 log 11y. Put a box in that, completely expanded. Look at the answer key. What are you seeing? 2/3 log base 11x plus log base 11z minus 5/3 log base 11y. All right, let's go to the next one. And that was number 10. We're going to go to number 11 now. And this one, you know, basically they're asking me to graph it. Okay, so when someone's asking to graph something, they're not expecting to get a great graph from this. But one thing I know is I know this is a log function. And when I say log, it's a natural log function. I know what they look like. And certainly I'm going to kind of start off saying that I know this is something to do with, you know, y looking like the parent, which would be the natural log of x. And if I were to graph that guy, this is the parent function, it would look like this over here. All right. Now, someone says, well, what's this one? It's a child of it. And what is it going to be? It's the parent shifted 3 units to the left. So I think I'm ready to put that down. I put that asymptote in now. So it's going to be 1, 2, 3 units. And that's going to be what? X equals minus 3. And I kind of know what it looks like. It looks like the parent. But what I want to do is I want to see if I can get, you know, what the X and Y intercepts are. And I want to go through it briefly with you. And so if I took the, you know, the y-intercept, let's write this down. And the y-intercept would be x is equal to 0, right? And what would you get? ln3. Now, if I did the other one, I set y to be 0. Let me see if I can do that. That would be 0 equals the natural log of x plus 3. E to the 0 would be x plus 3. Well, e to the 0 is 1, x plus 3. What would you give there? We'll take 3 from both sides. You get x equals minus 2. So I think I got that covered. Now, ln3, you know, e's roughly not, it's almost 3. So I'm going to say it's a little bit above 1 then. All right, let me draw my picture in. Okay, got that covered. Now let's say the domain. Let's write the domain down. Minus and 3 to infinity. Domain is done. We'll look at the key later. X-intercept. Oh, I think I did that right. X-intercept, write down for you. We just did it. Is going to be minus 2, 0. Again, we'll look at the key later. Vertical asymptote. When I did that, the vertical asymptote is x equals minus 3. All right, we'll look at the key later. What else did I say? Sketches graph, I did that. Let's take a look at it. Domain, we got this covered over here. X-intercept is minus 2. We got that covered. Vertical asymptote, x equals minus 3. Your graph should look roughly the one we provide you. The one we provide you is on the following page, which is figure 85, page 204. All right, I'm going to talk about SAGE, real brief. We're going to go over that. We're done with that. Not a bad section to do. And give me 1 second to do another share with you. Okay, so I'm going to talk about SAGE. And let's talk about that right now, related to SAGE code. I'm going to go back to my terminal. Again, for those students using CoCalc, that's fine. You don't have to use a terminal. I will say if you do plan to move forward in mathematics or into like an area that has computers in it, which includes engineering and computer science, of course, you should learn how to use command prompt. But I type this in, reset. Hopefully I'm learning by doing this. Remember, if you're using CoCalc, it's shift enter. X equals var. I'm defining a variable. This is Python code. And I'm going to keep moving through that. I'm going to start to copy things though. I'm going to copy this. Look like a familiar problem to me, by the way. Someone says, where did the problem come from? It's right from the notes, by the way. And, you know, f of, we'll go back over this. I want to point out, I'm just learning by copy pasting. I see that. That reminds me of the mortgage problem we did. It's a 30-year mortgage if you were paying $897.72 on a $150,000 loan. This one looks interesting. Again, I'm just copy pasting. I'm not saying you're learning. Learning is really a very problematic. It takes a lot of effort. And I'm going to put this one down over here. I'm learning. I'm not sure what I'm typing here, right? You know what? I'm going to type that one in, S, a square bracket. We'll talk about what that means later. S 0. We'll talk about it later. RHS. I guess I give us the right-hand side, right? Let's do that last line, which is dot n. I want to tell you what this thing is going to do. It's going to try to approximate the answer. And we got it, 1261. All right, 0.89. I want to go back over the notes, though. All right, what do you mean with the problems we just did? And talk about this. All right, so let's take a look. And I'm just going to briefly go through it. We're just looking back over these problems over here. All right, now granted, you know, I'd say number one is pretty easy. Number two is you definitely need a computer for that. And I think we just did that one. All right, let me point out what I mean by that. I just typed in, you know, f of x. I used x instead of the t. Let me do the t, though, for you, okay? So I'm going to define t as a variable. And we're going to learn by doing this, by the way. And I'm going to type in f of x, not x, it's t, right? Equals 16.625 star. And I want to point out in most computer algebra systems, log stands for natural log. And what's it going to be? T divided by t minus 750. Okay, hit the return, see what happens. Who knows, maybe I got an error. That looks pretty good. And let me see if I can do, you know, these functions over here now. And I'm going to do, you know, t, f of t. And I'm sorry, I didn't mean to do that. It is f of x. I'm so sorry. Let me just erase that. All right. So let me go back. I'm going to I'll start at the beginning. Reset. Let's take a look. So f of x, that's what t is, right? I'm sorry about that. Equals 16.625 star natural log x divided by x minus 750. All right, let's do the first one. It's going to be f, what's x going to be? 897.72. What does it give me? 30 point. Remember I said it's not exactly 30? Well, that's the number you get over there. Let's do the other one, f of, I guess that was $1,659.21. And that's not exactly 10 years, a little bit more than 10 years, right? So it's 10 point yada, yada, yada. And again, they're approximately equal to 10, approximately equal to 30. Let's do the next one. I'm going to do this computation over here. All right. So I'm going to say it's f of 897.72. Oops. Star 12. There's 12 months in a year. Times 897.72. And what number do we get? 323184.2. Yep, same number they got there. Do the next one. Let's put that one down for you. I'm just doing some computations over here. And that's going to be, I guess we did that, f of 1659. It's nice to have a defined function, by the way. Star 12, star 16, 59.21. I think you get the idea. Calculators really make life a lot easier. 199, 110.83. Yep, same number they got. And again, if you want to go through the rest of the computations, you can, and that's fine. You can take these numbers that we just generated and subtract away the 150 from those numbers and get those numbers over there. This one I want to talk about again, and that is, trial and error, right? Trial and error. So the bottom line with trial and error, the problem is it's solving an equation. And I want to point out what D is, and I'm going to go back over the notes with you, with the Sage. Sorry about that. It's this one over here, right? What is it? Solving f of x for 15. You also use a decimal over here. So I want to talk through this code over here. So it's actually solving the function to equal 15. All right, let me go back to the question. Trial and error, 15 years. We want it to be 15 years, all right? 15 years. We want it to be not 10 years, not 30 years, we want 15 years, right? How much would I have to pay per month if I was going to do the 15 years? So we need to solve that function for 15. We need to solve for x, all right? And again, I want to go back over the code again with you. I'm going to go back to this over here. All right, what happened over here? It actually writes down what x is, but a lot of people have no idea what that represents. None whatsoever. All right, but it gives me something. And then I'm going to say s is, let me write that down for you. It's what I just copied pasted above, right? And again, you could type that in, just types it right back. Here's the deal though. I hope you realize I'm looking at s, there's two sides to it, right? So if I do S0, let me put that down for you. What does it give me? It gives me the entry inside this. So it kind of reminds me that this is sort of like a listing or a matrix, and there's only one element in there, but the element on the inside is an equation, right? So it's this left side, right side. So if I do S0, that's the inside of S, by the way. Zero is the reason for zero is it starts counting at 0, and I type in right-hand side. What does it return the right-hand side of that equation? Well, what I want to do is I want to approximate that. So it's n approximate whatever that number is. What does it give me? 1261. Let me go back over the answer key though with you. I want to point out where that is. And it said use trial and error to do that. I'm not using trial and error, by the way. I'm actually using a computer to help me with it. And what is it going to be? 1261.89. Numbers right over here. Okay, that's what you have to pay per month for 15 years to pay off the $150,000 loan. By the way, that interest rate is pretty high. Okay, thank you.